see a piece of it.
Hello! Okay, then we have audio. Ah! Is it on the stream? Hello, welcome to the stream. Hello, 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 hello. Oh, it's just like 30 seconds delayed. You hear the freaking...
Just a casual 30 seconds of it.
No, I'm just gonna put waiting for stream to start. Okay guys, we're live. I mean, no one's watching, but like, you know, let's try not to say any profanity.
Will you text me the link to the stream? Someone? That way I can kind of watch it.
You hear a really loud noise. Yeah. And about 30 seconds later, you'll see it.
You're gonna hear the loud noise in the building first. Calling.
Thanks, folks.
I'm so YouTuber right now. You guys have no idea.
Stream will start.
Maybe I should quit engineering.
Yeah, funny.
I did consider it at some point actually, but then I realized there were people who were much better than me. Okay, does it look like that on the stream? The stream gets saved to YouTube, right?
If you set it to, I believe.
Yes, it does. Yes, it does show that.
It always does. Oh, okay. Shows the stream.
So how do I make sure it gets saved?
I'll Google it.
Okay.
You just go back and click the live tab. Previous live streams will appear. Hover over it. Download it, and then you can upload it.
Oh, so there's a time in which I can download it.
Yes.
Okay.
So once you end the stream, just download it right away.
Gotcha. Okay, I'm gonna set up the other cameras now. Is that me? No, it's not. Fuck, I forgot the blue tape. It's okay.
Yeah.
Jimbo! By the way, stream live. Yeah. Cool. That's your master. You have the webcam. You have the webcam. I tried to get the webcam. Oh, because the switch on the side is off. Okay. I'll be back then. Yeah, you turn it on. Yeah, that's my bad. Got an analog. So I want to hear, bro. All right, now it's on. Which audio is it running? Send it no fucking giant thing or whatever. Hey, are you on the edge? No. Okay. He said he was willing to put his balls here. We can have two concepts right over there and then like here. Whatever else you want to do. Oh. Okay, you got it's on now? Yeah. Okay. I mean, you don't have to.
I don't care.
Really?
It's my phone.
Yeah.
Okay, we're getting lots of slow-mo footage, I guess.
No, my phone is off. It's off.
You just have
So bad.
You have slow-mo footage?
Yeah, that's slow-mo footage, and it's so bad.
History of me knowing Fuser who's never had a good photo.
That's been 4 years.
Oh, look at that handsome face. Are we doing it? Are we doing it? Are we gonna do it gamer style, guys?
Yeah, for Cal.
You have another one that you're using?
No, just.
What's up, y'all gamers?
Yeah, that's why you're not PR lead. Jimmy is
Hello all, we are here. We are still getting our startup procedure all set and done. We are currently working on making sure our load cell is calibrated properly, and then we are installing every last little electronic bit that needs to go on. We have essentially everything connected up. This is our valve wall. The tall tank that you see is our pressure vessel, and then down there, which you'll see on the onboard footage, is our combustion chamber. We will be collecting everyone and setting up the proper procedures very soon. window? It's wide open. Right now? Alright. Alright, test. Hello. Is this audio working? Let's see. 2 seconds delayed. Oh, test. Alright, there we go. Hello. Perfect. Alright, so we are here. Hopefully, given everything continues to go as planned, which it is, we will be rolling through our entire procedure, start to finish. The first step, obviously, we've already been assembling our entire system. Then we have a pre-safety briefing and a setup briefing. Then once our entire system has been set up, we will go through our telemetry lead, make sure all of our values are correct at the start, make sure that all our tanks are at the correct pressure. We've already double-checked these, but we're going to go through a last triple check, of course. We're going to do a nitrogen line purge to then clear the entire system of any remnants of moisture, other particulate that could have made its way into the chamber lines. And then we will do a nitrous oxide fill sequence. That will be the most dangerous and the most cautious part of this entire situation, because we will need to both monitor the pressures and the weights of the tanks very accurately so that we don't throw them into overpressure. Our pre-test verification, so we will go through and make sure that all of our valves are closed or open in the correct position. We will go through all of our go, no-goes. Then we will contact our DPS officers that we have guards around the perimeter to make sure that our area is clear. We will then execute the test, and then we will do a post-event shutdown and cleaning. Then from there we will go through a debrief to go over the data, but that's likely where we will end our stream. And that's about it. We will be starting here very soon. I can probably update the T-minus. Huh? Okay, alright. And we will be just the webcam for now. But we will be right there. There we go. I apologize for the camera quality. As of right now, we have people walking in front of the line of sight of our antenna, so as of right now, the video will be cutting in and out. But once everyone is set up and the antenna is placed properly, there won't be any cutouts. We're live. Procedures. To explain a little bit more about the project to any of those of you who are watching, we are a senior design group here at SLU, and we are associated with the SLU Rocket Propulsion Lab. And our main goal for our senior design project was to create a hybrid rocket engine, which has never been done before by the Rocket Propulsion Lab here at SLU, and to not only make one that works, but make one that works efficiently, intelligently, and safely. And we have and also have the capability of putting it into other standard airframes of that size. So it can essentially be reused and modularized into other rockets in the future, which will, in total, raise the ability to do research for the Rocket Propulsion Lab in coming years. Hold on. Awesome. Yeah, Jonah's talking about it.
Jonah is talking?
And yeah, where is Jonah? Is Jonah not out there? I'm doing an intro right now, so hold on.
No.
So as I was saying, the purpose of the project was to make an intelligent design that is able to make weighted projections against the rocket's trajectory, and then using that data, it can collect.
Underwater nitrous tank?
It can collect its data and then make a prediction where it can then shut off its main engine valve and coast to a selected altitude at launch. So say we tell it to go to 10,000 feet and we want it to be within plus or minus 1% of error. It will then be able to launch itself, shut itself off at the correct time, and then coast to that altitude, which is our desired result. Also, because it is a hybrid rocket engine, it is able to be modularized and made into a much more safe configuration than a solid motor, which cannot be turned off once it has been ignited. With the hybrid rocket engine, we can then, say, put in over-temperature situations, over-pressure situations, a bad trajectory event. Any one of those situations, the rocket will then be able to identify and then shut itself off immediately without us having to intervene. So that's just another safety feature of this hybrid rocket engine that we made a priority to implement. The main reason for the size of the motor, it has a 4-inch diameter, is because it is that diameter to fit into most standard airframes for this class of rocket. For most solid motors, they take that same airframe, and so we want our rocket propulsion to be able to use this rocket in the future and reuse it. So it needs to be able to fit into really any airframe that the club creates. So that is the main design limiter for why we chose the size that we did. What you see on screen right now, right in the center, is our combustion chamber. It is pointed upwards, and it is cinched down. It is all tight. But that is where our actual flame will be coming out of. Behind the camera is our pressure vessel. It's much bigger. It's about 9 feet tall, and it holds about 14,000 cc's of liquid nitrous. About 20% of that liquid nitrous is gaseous in the tank, but most of it is liquid. We've ensured that all of our parts are cryogenically stable with previous testing. We know that they all can handle the forces. A lot of our parts are rated to above 3,000 psi, and 3,000 psi is the largest pressure that we will ever be seeing in this system. What else? We have also made a few automated fail-safe switches. We have made sure that a lot of this system is pretty fail-safe in general. If you can see in the video, we have the rocket down below a retaining wall so that this whole situation is generally safe in the event of an emergent situation. If something explodes, which it won't, if something catches on fire, we have multiple layers of safety to retreat to in case anything bad happens. We have emergency abort procedures and other procedures to make sure in case something happens, we can deal with it. But overall, 90% of the you know, what we do is just hit the off button and run. So that's how it's going to work. But we know that that is not going to happen. We have a bunch of people actually all the way across. We can't really show you. I don't know if you can see it right on top of that garage. You can see a bunch of people starting to form. That's where we're having our viewing area from. We've roped off essentially the entire field area, and we've placed DPS officers at intersection points so that people can't come in.
You have your live stream open on your phone?
Do I what?
The YouTube video live stream?
Yeah.
So you can like see the comments if you are asking more.
Yeah. No, we've placed DPS officers at intersection points so that people can't come in.
You have your live stream open on your phone?
Do I what? Yeah.
So you can like see the comments if you are asking more.
All right. Oh, I see NHM Connect is in here. NHM Connect is one of our sponsors. They helped us to buy a few different parts for this project, so we are very grateful to them. Go check them out if you need any kind of work that they do. We are just now finishing up getting, if you can see Jimmy on the screen, he's getting the alligator clips clipped in. Looks like we are connecting up the last bit of our pressure transducers. Just verifying that everything is in working order. And yeah, we should be good to go very soon. But if you guys have any questions, feel free to put them in the chat, and I would be very great to answer anything that you guys want to ask. Is that red marker over there? You see the red marker over there, Howlai? Red marker. Is it over there? If not, it's fine. It's fine. It's fine. I got it. I got it. All right. This project has been a long time coming. Our rocket propulsion lab over the past couple years really took a dive, especially when I came into the school. They really weren't doing anything, which is not a fault of the students at all. It was just kind of a circumstance. And so really the only cool thing the rocket lab was doing was launching model rockets, which, I mean, is cool if I, was 10. But we had to start somewhere, so that's where we started, rebuilding the club. And over time, we graduated from Cert 1 to Cert 2, then to Cert 3. And so now we are going to, last year we went to Spaceport America. This year we're going to Spaceport America. Hopefully we win this year. We won't be taking the hybrid engine with us just because it won't be ready in time in terms of getting a rocket built for it, because its total height is around 12 feet tall, which is huge for a Cert 2, or Cert 3, I'm sorry. But in general, we're loading the nitrous now. We'll cut to that soon. But in general, the Rocket Lab has just been on a slow but steady uprise over these past 2 to 3 years, and now we have been able to get it to be a part of some really great projects. To clarify, one of our sponsors, NHM Connect, they are they're a government and corporations relations firm in Ottawa, Canada. So if you ever need to do anything with the Canadian government, they are probably the people to talk to. Speaking of Canada, we definitely got a lot of help from a team in Calgary who did a very, very similar project. They developed a tank from scratch, an entire system from scratch, just like we did. And so we used them as a resource for this project a lot. So we would like to give that team a shout out, and we have and will be shouting them out in our academic papers as well, because their help really, really did allow us to get this project going. There's a lot of small bits and niche parts of these projects that you wouldn't know otherwise if you had learned it from somebody else. And some of them are safety based, so it's a good thing that we had that resource to go off of. Okay, we can show you guys the pressure vessel. I'll do that right now. Just go to webcam. Oh, no, let's just go this way. Okay, so here's the setup again. We're loading in the nitrous tank right now. Here's our valve wall. These are our main solenoids that we're controlling for filling and then for purging. We have safety valves in there too, pressure relief valves, and readers as well. Then if you come over here, it's treacherous. You can see this is our pressure vessel. You can imagine those two pieces stuck together on top of each other, and that is the entire size of our engine. It's quite large. That tall tank right there holds about 14,000 cc's. Small one is our combustion chamber. That's got our convergent divergent nozzle in it, and it's got everything else, including our acrylic, solid fuel, and our igniters inside. But yeah, that is the general setup around here. We're standing in Oliver Hall. This is our wind tunnel building. Hello, Jonah. That's good. But yeah. Let's see. Cool. Let's see. All right. So, getting very near here. I could probably change this again. About 5 more minutes. Does anyone want to let the people know up top that we're getting really close? Well, we'll call Ava.
That's the wrong tank. Pull that tank out. This is the tank you want to put in there.
Yeah, that was the wrong. This is the tank.
The tank you want to put in there.
It's okay. It's okay.
No.
All right.
So that tank, you're going to need to, I guess
Let's go the other way. Let's turn around the other way.
Yeah, I know.
Yes, where is Scott Manley when you need him? Great.
Master Chuck?
No, you guys are going to do the hard work.
Alrighty.
That's still the hard work pushing that side.
Let's just put this in. Yeah, that's good. Alright. Alright, so now we just a little bit of a waiting game. We're setting up the nitrous tank, plugging in the correct tank, not an empty tank. That would be bad. We have everything. We just triple checked all of the valves work. They work. We know our load cell works for monitoring weight now, and we know that our thrust load cell works now. So that's all of our data sensing equipment fully checked. And then once we know that the tank is connected, we're going to issue all non-essential personnel out of the area. We're going to confirm with DPS and make sure that all the rest of the area that we can't see, that or at least is out of view, is clear, and that they know to make sure nobody passes by at all costs. Well, obviously. And then from there, we will launch. The fire should last about 5 seconds, but it will be hopefully glorious. Bless those people for standing up there on that hot garage for a while, waiting. Hey, Ben, can you tell, I'm gonna, here, can you just go ask, Jimmy for, Ava's number? The girl that's up there? I would be down there helping, but I feel like I need to stay up here and make sure that the stream is both running and that also our data is coming in correctly. Jeez. Alright, I just let them know on Slack to go up, go to the live stream, so hopefully they join up. Hopefully that they can then, if they need to communicate with us, they can just send it through the chat. Ask us questions as needed.
He's up top there, if you want to call him.
He's
He's in the audio right there.
Who is?
I call you, John.
Okay. Let's see. Hey man, Katy Perry going into space was great. Totally cool. Probably one of the biggest wastes of rocket fuel I've ever seen in my life. Hold on. Hey, so you guys are up there. Join the live stream so you guys can get an update. It's about probably 10 minutes about till we're just getting all the final fuels connected up, and then we're gonna issue everybody out of the area. No, we're just gonna issue non-essential personnel out, you know. But yeah, get everyone on the live stream so that if you guys have any questions, I can answer them over here too. All right, bye-bye.
Is it the one that we used the first time?
Yeah.
What are you guys looking for?
Nitrogen regulator.
It was on top of the valve wall. Is it not right there? Yeah, we got it. It's right there. Okay, so a few people are also asking what's the difference between solid and liquid rockets. So many rockets that you see, or almost all of the ones that you see flying up like SpaceX rockets, those are hybrid and liquid rockets. Hybrid rockets are a combination of liquid and solid. Solid rockets are just fireworks, so you can get a small firework or you can get a huge firework, but they all work the same. You light them, they go. And a liquid rocket is when you take two different kinds of liquids that react together with a combustion, and you can feed those individually and get a really precise, really powerful engine. Both can be powerful, but liquid engines are a lot more precise and fully controllable, whereas solid engines, you light them, they go, that's it. And a hybrid engine is the child of both, where we get lots of performance from the solid motor, where we get controllability from the liquids. And so if we want to say turn off the engine, which you can't do with a solid rocket, we just turn off the liquid. And then the liquid, which because the solid needs the liquid to react to create a boom, it all stops. So it's a lot safer, and it allows us to then create an intelligent system that can turn on and off. So that's the main reason why we chose a hybrid engine. If that wasn't clear already. What are you looking for?
TPE tapes.
Tape? Yeah. Oh, TPE tape.
This is
It should be in one of those boxes right there. It's the blue. It's a pipe tape.
I know.
You are except what tape is.
Yeah, it's in one of these boxes.
Frank. It'll fit there. Just oh yeah.
Alright.
You have it?
I don't know why you guys can't find it. It's in the.
I'm gonna move this up just to 10, just so people know. Jimmy, would you like to, or well, we'll do a little intro once we're all ready and set, okay? All right. All right. Sorry to delay slightly, folks. I was a little bit jumpy on the time. It's definitely a little bit more likely to be 10 minutes or less. Hold on.
You guys connect shells here? When each connect this regulator, that connects the bottle.
Alrighty. So we should be closing in on our time very soon. Oh, you think 20 minutes? All right, I will update it. Sorry to delay. Just to ensure that everything is safe, we will add 10 more minutes. Let's just change that really quickly. Yeah.
What's your name, by the way? Captain. Who, me?
For you.
When we do the test, we will ask you to go either behind the building or to that.
Yeah, I'm just popping in and saying, look, Frank, good to meet you. Yeah, am I on the list?
Yes. You work here, Frank.
What does that mean you're on the list? You're on the list of invitees?
I'm on the list to be back here.
Okay, all right. So, this door, is it alarmed?
No.
It's carburetor on the outside. No. Okay, Scott was
Everything. We are all good? All right. But yeah, I'm open, so while we're waiting, I can answer some more questions. Apologize for the mic quality, by the way. It's fortunately just my laptop. Let's check those comments. Alright, got some more people in the stream, that's good. Hopefully some of the people watching up on the garage are in, so that they know when we're about to launch too, because I don't want to keep them waiting for too much longer either. Thankfully it's not too hot today. The last time we did this, it was pretty hot outside. But it also means our safety factors for our tanks are a lot better because they're not sitting in the hot sun all day, and nitrous can sublimate and then explode. Even with down to, at least with our measurements, it would require about 1 joule of energy to go off with heightened pressure. So thankfully that pressure won't be raised, and our factor of safety will be about 2 times higher, just with about 15 degrees less in ambient temperature. PB1, PB, okay, good. All right. That was a crucial Starbucks cup, apparently. We all good with the solder?
Yeah.
All right, cool. special launch keys. Yeah, if you guys are wondering what this is Big Blue, St. Louis University's large-scale wind tunnel test. We keep it here in Oliver Hall, and we get to use it a lot as students for whether it's part of a class or if we are in one of the various sub clubs like the aerospace lab or the rocket propulsion lab, or if you're just doing something for your senior design where you need to use a wind tunnel. We always have access to one. It's great. We also have a supersonic wind tunnel here. Very top secret, really, not really, but a lot of companies come around the world to use it, and it is a big part of the research here at Parks Aviation, which is Parks is part of SLU. Essentially, they're the same thing. But Parks originally, Parks Engineering College, was its own university, and then I forget exactly when, but St. Louis University bought Parks and integrated it into their campus.
Show me where to go.
What's the propellant about answer?
We're using acrylic and nitrous, liquid nitrous.
Okay. Yeah, so it is. Oh no, we need
Thank you.
I'll see you, Frank.
Propellant is inside.
So the logical next step of development is both fully integrating the rocket into its main body. So we have the rocket essentially in two pieces. If you took the rocket like this, pressure tank and the combustion chamber, and we just turn the combustion chamber upside down. So we already have, there's a central part that connects the two, a bulkhead. We've manufactured that, we just don't need it because we're not putting it inside a rocket. However, we will take that, connect the two, and then the rocket is designed in a way where it's very easy to just put into a rocket body. So the engine will be finished at that point, and we, at that point, only need to really focus on the control hardware and fine-tuning it to the specifications of an actual built rocket rather than simulations that we've done. So with the simulations, we've confirmed that the rocket has the ability to both sense its trajectory, and then using that, I mean, it's a simple if and then, turn itself off. So we know that through simulations it can do that. And so the logical next step would be integrating that control software into the engine, doing some more tests with probably on the ground, taking live data, maybe mid-test, introducing an error so that the system can shut itself off. That would be a good next step. Unfortunately, we don't have the money for another couple tests because it costs about $500 to fire this every time. And as we're coming to the end of the school year, people are leaving. We just don't have the capability to really delve into that right now, but I will be staying back for a little while. A few other of my group mates will be staying back. So we will try to get as much of it integrated as possible, but this really is also just an ongoing project that will really benefit future students next year and the year after. I mean, we built this engine to last, and so we do want it to be used for many coming missions in the future. Really, the only part that will ever need to be maintained and replaced is probably the pressure tank. After repeated cycles, it will start to degrade. And also, obviously, we use graphite nozzles, and our combustion chamber, which is made out of 6061 aluminum, will degrade after a while. But all of our solenoids, all of our pipe fittings, all those are designed to last. And so, especially with our valve wall, which is a very, very big part of this project. But yeah, it's the logical next step would just be integrating the software into the rocket and performing different emergent situations live. So whether we want it to simulate for real, like simulate with a hot fire test, a stopping of the engine to coast, or we want it to say react to live data. So if we we could take its internal geometry or internal sensor, turn it on its side so that it thinks that it's, oh no, I'm pointed the wrong way. Okay, well, turn itself off. Or say we feed it incorrect pressure data. Say you're at 1,000,000 psi. Oh my God, shut off. or we feed it the infrared temperature data and tell it things are way too hot. Then it'll turn itself off. And so once we've confirmed that all works, then it's just put into the rocket. Seems like, yeah, I know I'm making it sound easy, but it really is that easy. Where we designed it so that it could be just like a solid motor, so that all you have to do is put it in the rocket that you've made, and then hit the go button, and then it'll go. So that's where we hope this will go over the summer and then into next year, and then at Spaceport America Cup next year in June next year, 2026. This rocket will hopefully be there. Let's change that to T-10. No, that does not have audio down there.
The air gas supplier, there was another gas supplier about a mile away called, I think they were called Minewell, and they blew up. It was unreal. Even they asked them.
We have 31 viewers. All right, that's good. All right, it is taking a little bit longer than we thought, but it should be okay. I'll be right back.
Another 20 minutes.
Guys, don't say it in front of us. We are skipping classes.
Another stream, 20 minutes, Jack.
All right, yeah. All right.
Doesn't matter.
Oh Lord. Everything's all good now, but we brought an empty nitrogen tank. Our nitrogen tank is used to boost our nitrous into our fuel tank. There's another one just right on campus. We're bringing it over, but it should be a few more minutes. All is good. Simple mistake. Those things are heavy regardless, so they must have picked one up, thought it was full, and then brought it over here. It's okay. We're just they're gonna run over to the chemistry department and pick up another one. So no problem. Everything's working. Right, Jimmy? Everything's all set up and good? Except the nitrogen tank, yeah. Would you want to introduce yourself really quick? Or are you good? Alright. This is Jimmy, our team lead.
Yeah, I'm Jimmy. I've led this senior design project. Jack is the safety lead. We have Hal Lai too. He's the pneumatics and electrical lead. And we also have Ben Katsefum, and he is the telemetry lead. So that's basically monitoring the fill tank pressure and weight so that we know that we're filling our oxidizer up to 20 pounds. That's the target weight, and then that gets purged through the system. But I guess a little introduction, I'm a senior at SLU. I'm from St. Louis, and this is the first hybrid that SLU has developed this far, so we're hoping it goes well.
Very hopeful. A team attempted to build one in 2019, and it's not that they didn't get very far. They got pretty far, but they never really made it to actual fully testing, and weren't able to continue past that, and so we kind of picked up where they left off. We're going to test pneumatic valves? All right.
Where do you think you listen to?
Alright, you guys can see this. Alright, we're on.
Fill 2. Okay.
Woo!
Wait.
I turned it off there.
Yeah, I know.
Yeah.
Just wait.
Alright.
Fill 1.
Just fill, you mean?
Yeah.
Okay.
Okay.
Good?
And when I tell you to do purge, keep it on for a little bit.
Okay. Where, yeah, I gotcha.
Purge now. Okay.
Sweet! Alright. Those were good noises.
Make sure the key's out.
Yeah. I don't think I want to tell Jimmy that. We've spent a pretty penny on this, and I don't want to mention any more about that. But if you want to donate, we will be putting out our SLU RPL PayPal, so that if you want to give back to the club or sponsor any future projects like this, you can. And we'll put your name on the rocket or whatever. Whatever you want, really. We're very open. Very open. Alright. But yeah, I guess now we're just waiting for the nitrous to get here, or nitrogen to get here. Alright, I have our nitrous. Yeah. We're doing alright.
What should we do? Any ideas?
We have 31 viewers. If anyone's on the live, oh. Hello, Mom. Hello, Dad.
Oh, where? Did you see the Woodruff graduates for their students?
I see. They need to be let in. No, they don't.
All right. Cool. Nitrogen is here, so you're getting very close. All right. We got the GoPros ready to record. Are the GoPros ready? All right. My GoPro's ready too. We're gonna get some phones viewing as well, just for legal reasons. We should probably film us as well, just for safety, just in case anything happens. Nothing will. Nothing will. But we've taken a lot of steps to make sure all of this is safe. After doing some calculations, we found out that anything past 6 meters, if our pressure vessel were to rupture and explode, is perfectly safe for us to be, and that, yeah! All right, safety glasses on, safety pro on, it's time. Yeah, this is so small.
Did you guys check on the regulator?
Yep.
He's coming over now?
I don't know if he's coming or not.
Yeah, he said he wanted to come soon.
Alright. Glasses on. Hi, Kate. Mods, kick her out. Alright. Keep that there, yeah.
Whose Pepsi is that?
Where's Ben?
I don't know. Oh, Ryan's.
Where's Ben?
I think his son go that way? I don't know. Oof. Oof. Keep that hat on. How are we looking?
Good, I need Ben, remember.
Alright, did he go to the bathroom or something? Ben! Get your ass over here, man!
You sit here.
Hold on.
Valves are already checked. Everything's fine.
Get on the procedure too.
Already? Alright, cool. Alright, we're gonna run through the safety soon.
Huh?
Yeah.
Thank you.
Alright, we are starting. We'll do T minus 3 minutes.
Oh, we needed the NASA coverage where you guys were talking to the people.
Yeah, that's what I'm doing. Yeah. Answering questions and whatnot.
What about the weight fit?
Your voice? Yeah. Oh, alright, well, I mean, we're live right now. They can hear you. This is Andrew, member of the RAD Propulsion Lab. This is Ben. Ben, say hi. Stick your hands.
I'm okay.
All right. I'm gonna do a quick intro once we're all set and ready.
You can record this too, on the bottom right hand.
Can I minimize this? Like or just
The hitman before, then you
oh,
can
oh,
minimize.
that.
Yeah,
There.
record just in case we lose.
All right, cool.
Oh, what happened to the stream?
Oh,
Oh, maybe it can't show and record at the same time.
okay. Well, let's not do that.
Yeah.
Wait, no, it's this one.
Start the procedure, Jack.
All right, hold on. We're just making sure this.
I got it. You do the
All right,
procedure.
there we go. All right. We need a safety briefing, so I need everybody to stand over here. It'll be good for the fun. We always need a compressed air tank.
We did. No. That's why it broke in the first place.
Are the GoPros recording?
Yep.
Yes. We can try this if you want. The window has a mesh behind it. This one's better. Protecting my beautiful face. No steel coming this way.
Wrench?
What kind of wrench?
2 wrenches, 2 crescent wrenches. That's what we're looking for.
Where's the one you?
Right here.
I need one more.
The one was there.
Right here. We have another one.
Why are we not clear?
All right. I'm gonna start the safety briefing, if that's okay.
Yeah.
All right. So everyone's got their safety pro on? Yep. So for emergency procedures, they're pretty simple. If we have a leak, the first thing we do, me and Jimmy will disarm the system any possible way we can, and then from there we will evacuate out that way or out that door, depending on which way is safest.
Jimmy.
Everyone here is in a good position. All of our spectators are out. We're going to do a little walkthrough, make sure nobody's outside of the field.
We're starting!
Sir. Let me say you got this. Yeah. Here you go.
Thank you.
All right. Let's go back to safe procedure.
Yeah, it works.
Then, so our pressure relief valve are operational. Yes. Nothing blocking them. Nothing blocking them. All right. Radio and comms are operational. You got the data up. All right, data's running. All non-essential personnel are cleared from the test site. All right, so we've connected the 120 psi air compressor, and we just confirmed that 80 psi is coming out of regulator 1. That is correct. All right, well, where's the marker? Where's that red marker? All right. 120 psi, and all right, so it's good. Open manual valve for the pneumatic system to pressurize all the solenoid valves. We're good?
Yep.
All right, that's open.
Yeah. Okay.
All right, so it's open. All right.
Hey, Michael.
Hey.
Yeah. Like, I was worried. Then I saw the whole road thing blocked out, so I was like, I don't think I understand.
Data stream, power on into your verifying logging system, correct? Alright, ensure PV1, PV2, and main engine valve are closed, correct? Closed, okay. Pressure relief valve, yeah, those are closed. We got our nitrogen and nitrous valves open. Both valves are open. Both valves are open.
Remember how loud these things are?
No, the nitrous is not open.
Okay, nitrous is not open.
You want to check the valves?
Oh, you're uttering like way louder than the other.
Here guys, while we're doing the safety procedure, just
Yep. Thank you. It was fun.
I'm not stopping you. It's Operation Human Shield.
A little bit low.
He has a kick to feed too.
Here, shield.
Alright, open the nitrous manual valve. Alright, open the nitrous manual valve. Back up. Next we go.
Yes.
We don't need this.
Yep, we're ready. Opening valve.
I'm gonna watch actually. Save that seat.
Okay, I need this. No.
Hey, wrenches, two wrenches.
Wrenches, two wrenches. Two wrenches.
No,
Two wrenches. Okay.
Right there.
Alright, we're opening those. We're good.
You cannot. So they probably give me time.
Okay.
Just feed it.
Alright, T-minus 2 minutes.
Here, Lennox. Yeah.
If they had a automatic procedure,
Alrighty.
We had a whole like circuit breaker with all of like the electronics.
Alright, Jimmy.
Basically that.
Okay, we're up to a valve.
Next
Okay.
is line merge. Ready?
Let's go.
Alright, line merge.
Alright, ready?
Is this on?
yep.
Yep.
It's perfectly safe.
Everything's on.
They should not.
Yep.
No, it's not about.
Everything's
Everything's
connected.
connected. Alright, open MV1.
Scoop up there.
Yeah.
We're gonna do a nitrogen purge really quick.
Open MV1.
Just swing that up.
Yep. We're doing a nitrogen purge. We're cleaning
Okay.
the tank.
MV1,
MV1, open.
which is, hold on. I just gotta double check this.
Okay, yeah.
For my sanity sake.
Just double check.
Right there.
Yeah.
You see the red channel locks? Yeah, it's right there.
Doesn't help to triple check.
Okay.
Alright, good?
Yeah.
Alright. Got them identified?
Alright, I'm gonna open the nitrogen valve.
Okay.
Ready?
Yep.
Okay.
Filling?
Call up.
Which pressure?
39 psi.
Alright, we need to adjust regulator 1 to 950. It's already set to 950?
84.3 psi. 98 psi. 112 psi. 127 psi.
Say it a little louder.
141 psi. 155. 169. 179.
Okay.
190.
Okay.
200? Alright.
Now,
Open
nitrous.
PV1.
You ready? Everybody ready?
Everybody ready for nitrous?
Opening PV1 in 3, to one constant pressure.
186. 285.
Say it loud.
355.
Louder.
Louder.
415. 426. That's
No
1
leaks.
kilogram. 433. 1.5 kg.
System looks good.
443. 2 kg. 461. 2.55 kg. 464. 286 kg. 475. 3.5 kg. 485. 3.67 kg. 500 4 kg. 500 4 kg. 500 psi 4.25 kg. 513 psi 4.4 kg. 421 psi 4.78 kg. 528 psi 5 kg. 531 psi 5.4 kg. 535 psi 538 psi 5.85 kg. 538 6 kilograms. 542 psi 6.23 kg. 545 psi 6.34 kg. 542 psi 6.54 kg. 545 psi 6.73 kg. 542 psi 6.9 kg. 545 psi 6.99 kg. 7 kg. 542 psi 545 psi 7.25 kg. 542 psi 7.37 kg. 542 psi 7.55 kg. 542 psi 7.66 kg. 542 psi 7.8 kg. 542 psi 7.9 kg. 542 psi 8 kg. 538 psi 8.14 kg. 9 kg.
Pressurize a bit more.
538 psi 8.3 kg. 540 psi 8.37 kg. 535 psi 8.5 kg. 8.54 kg. 538 psi 8.7 kg. 538 psi 8.74 kg. 535 psi 8.8 kg. 8.89 kg. 8.94 kg. That's more full. 9 kg. 9 kg.
All right.
Okay, I'm gonna open.
All right, vent for 30
nitrogen
seconds. Yeah, 30 to 60.
line, closing nitrous line,
Closing nitrous.
opening nitrogen line, monitor
Oh,
pressure.
PV2 then.
538, 566, 584, 598,
System looks good.
608, 616, 619, 619, 623, 623, 623, 626, 626, 626, 630.
Okay, I'm gonna put. We're losing a little bit of nitrous. I'm gonna close this. It looks like this is what we're gonna get to.
Okay.
And I'm going to put a little bit more nitrous in.
Okay.
Okay. 3, 2, 1.
630 psi, 7.8 kg, 626, 7.79 kg, 7.77 kg, 623 psi, 7.72 kg, 7.7 kg, 619
Okay, it keeps going down. I'm gonna go for it.
All right.
Okay, ready? I'm gonna ignite. So, armed,
Nitrous fill super. Yeah. Okay.
and I'm going to ignite in 3, 2, 1. 1, 2. Oh my God! Wow!
You pulled the key. All right.
Oh my God!
Yep.
Hey, what's the pressure reading?
Yep.
Let's see.
Make sure this tank is safe.
Yeah. Everyone everyone back up. Everyone back up. We're good? 20 psi? All right, we're good. Holy moly.
Holy moly.
Everything looks good.
Check the thruster.
That was probably the loudest thing I've ever heard.
Yep.
Jonah. Oh, I know you.
But they did say it's really loud.
Yeah, I don't know why we weren't wearing hearing protection. That might have been good. What did we reach?
700 pounds.
700 pounds? Yeah, that sounds about right with the like a little bit lack of nitrous. That's perfect.
Wow.
Holy fuck! We did it! We did it!
Go, guys.
Oh my God.
That was awesome.
Jimmy, good job on that igniter, man.
Yeah.
That thing works great.
Oh my god.
All right. Well, that's it, folks. Successful test. We got about 700 pounds of force, which makes about sense. We made it for about 1,000, but we were a little bit low on the nitrous just due to a small leak, so it operated exactly as we predicted, and if not better. That was amazing. So thank you all for watching.
Wow. Wow.